Hello everyone and welcome to Mech 142 Lab. My name is Oliver and I'll be your TA for this quarter. Each week I'm going to walk through the lab handout, and if you have any questions please email me, and keep an eye on the announcements page because I'll be posting questions or answers to common questions there. Okay, let's get started. So this is Lab 1, block diagrams. Here are learning objectives. You can read them on your own, and let's get started on polynomials. So to make a polynomial in MATLAB, we can just make an array of the coefficients of that polynomial. So 1, 3, 0, 4 would simply be 1 times s cubed plus 3 times s squared plus 0 times s plus 4. So you need a 0 for s, right? Otherwise, if it was just 1, 3, and 4, this would only be 1s squared, not 1s cubed. Alright, makes sense? Please email me if you have any questions. So if we want to find the roots of a polynomial, right, we specified the polynomial here via its coefficients. So if we use the roots function, we can get the roots of the polynomial and store them in an array called R. And lastly, if we knew the roots of a polynomial and we wanted to reconstruct that polynomial, we can use the poly R. So if we just knew these roots, then we can reconstruct the polynomial. Okay, let's move on to multiplication of polynomials. So that is just simply the con function here. So if we make two polynomials p and q, where p is 3s squared plus 2s plus 1, and q is s plus 4, then we can just use the con function, and then we'll get n, which is the array of coefficients that is the multiplication of p and q. Okay, so then if we want to plug in a value for a polynomial, let's use n here, plug in a value for s, then we can use the polyval function. So if we want to plug in -5 for s into the n polynomial, which is here, then we'll get -66. And note that we're using s instead of t, and that's because we're using the frequency domain. So s is going to be units of frequency, so usually readings per second. Okay, let's continue to transfer functions. So to make a transfer function in MATLAB, you make the numerator polynomial, and then you make the denominator polynomial, and then you can put them together using the TF function. So here we specify the numerator is 10. Be careful, it's not 1 and 0, so it's not s plus 0, it's 10. And the denominator is 1, 2, and 5, so s squared plus 2s plus 5. Okay, so we can make the transfer function by using the TF function here, with the numerator as the first input and the denominator as the second input, and we spit out system 1 here, right? So we have 10 on the numerator, then s squared plus 2s plus 5, right, on the denominator. So let's make a second transfer function here, right? So we have system 1 and system 2, and then we can add the systems together just by using the plus key. So just like you would, in your calculator. In MATLAB, you can just use the plus key and it'll add them together. Okay, so the poles and zeros of a function can be found using the pole function and the zero function in MATLAB. So with the input of system, you can spit out the poles, and input of system, you can spit out the zeros for the given functions. So let's make a transfer function here, right? We can just directly input the numerator and denominator as s plus 10 and s squared plus 2s plus 1. So here it is, and then the pole function gives us the poles, and the zero function gives us the zeros. And poles, just as a refresher, are values of s that make the system go to infinity. So they're the roots of the denominator. So you plug in -1 for s, and this goes to infinity, right? You end up with 0 in the denominator. And the zeros are kind of the opposite. So they're the roots of the numerator. So if you plug in -10, right, this transfer function goes to 0. Okay, and if you did not want to use 2 lines of code, right, you don't want to use both the pole function and the zero function, you can just use the pzmap function, and that'll find the poles and the zeros for a system. And they'll store them, if you specify it, into an array of poles and zeros. So big P is going to be an array of poles, big Z is going to be an array of zeros for a system. So let's do an example for transfer functions. We'll specify the numerator g, so g of s numerator, and then g of s denominator, and we'll put them together using the TF function. So and then we'll find the zeros of that transfer function, and the poles of the transfer function. Okay, so now let's move on to h of s, which is going to be a little bit more involved. It's actually a product of 2 numerators and a product of 3 denominators. So like we did earlier in the video, we're going to multiply, right? So we need the con function. So h of s is actually these numerators multiplied together divided by these denominators multiplied together. So we'll multiply them with conv, so n1 and n2, right? That gives us our numerator, and the denominator is going to be conv d2 and d3, and then we're going to conv that with d1. So you can only do 2 at a time, right? It doesn't matter the order. So you can do, conv d2 and d3, right? That multiplies together, and then you can do that last d1. Put them together using the transfer function, the TF function, and then we get this. And if we want to divide g of s by h of s, right? G of s is this guy up here, and h of s is the one we just solved for, then we can just use the slash key. So just like you would, in your calculator. And that gives us the following transfer function. And if you want to plot the poles and zeros, you use the PZ map function. And the reason why it didn't plot before is because you specified you want to store them into an array. So if you don't specify the variables for storing these values, it'll just plot it for you. So here's the plot. The zeros are the circles, and the poles are the x's. Alright, moving on to block diagram models, we'll start with a series model. So we have system 1 feeding directly into system 2 and giving us an output of y of s. So we can make the equivalent system in MATLAB by using the series function to give us the equivalent system sys, or series, right? So we have system 1, system 2, and if we wanted to do this by hand, and if we knew g1 of s and g2 of s, right, if we knew the two systems, we can make the equivalent system by just multiplying system 1 and system 2 together. So let's do an example. So our first system is going to be s plus 1 over s plus 2. Our second system is going to be 1 over 500 s squared. And so we specify, right, we make those transfer functions just as we've been doing before. And in MATLAB we can make the equivalent system using the series function with the 2 inputs, right? We get our transfer function. And we'll note that it's just the multiplication of the two functions, right? For a series system like this, the equivalent system is just the multiplication of the two functions. So s plus 1 times 1 gives us s plus 1, right? And s plus 2 times 500 s squared gives us 500 s cubed plus 1000 s squared. Okay, moving on to parallel systems. So this is different, right? Because we have u of s feeding into these two different systems, and then they're being added together to give y of s. And in MATLAB, you just make the equivalent system by using the parallel function. And you can think about this as u of s times system 1 plus u of s times system 2 gives you y of s. Moving on to feedback loops, let's say we have system 1 with a unity feedback loop. Unity meaning that you're just taking the output of system 1 and you're feeding it back in so that it's being added with the input to system 1. So there's nothing being done to the output as it's moving into the input. So to do this unity feedback system, we have the feedback function here, and our first input for that is going to be our system receiving the feedback. And then we have 1, meaning that we're not doing anything to it. We're just multiplying the feedback by 1, a value of 1. Notice that it's in brackets, right? That's important. And then the sign. So are we adding the feedback or are we subtracting the feedback from the system? So plus 1 means we're adding it, and a minus 1 means we're subtracting it. So you'd have either a plus 1 or a minus 1. It also turns out that if you don't include this, MATLAB will assume that you're doing negative feedback. So that's another option. So let's do an example of feedback loop. So we have system 1 and system 2, and this is another example. So instead of doing unity feedback, right, we're up above, we had unity feedback, meaning that there's nothing being done in the feedback loop. You're just looping it back, right? over here we have system 2 being done to the feedback. So we're taking the output of system 1, it's going through system 2, and then that is being added to the input of system 1. So we do this by using this feedback function, with the first input being the system that is receiving the feedback, the second input being the function in the feedback path. Before it was just 1, right? We're multiplying the feedback by 1, so basically doing nothing to it. And here we have it, some operation being done. And then we have the sign, right? Same as before. Are we adding or subtracting the feedback to the system? So here's an application. Let's say we have GC of S, which is S plus 1 over S plus 2. And we have U of S, which is 1 over 500 S squared. In series, we know that this would just be the multiplication, and we can do that by using the series function here. So we can simplify these two functions into one function, which we'll call system 3. And then to simplify the feedback down into one transfer function, we can use feedback function here, right? So the system 3 is the series equivalent, and then we have just 1 in brackets, meaning that it's unity feedback. We're not specifying the sign, so MATLAB is going to say, okay, we're doing negative feedback. And this produces the following transfer function, y of s over r of s. So let's do another example here. So we'll make our transfer functions for g of s and h of s, and we'll do the feedback for h of s being the feedback and g of s being the system with the feedback being done to it. So we do this again, feedback system 1, right? System 2 is our h of s in the feedback path, and we're not specifying the sign, so MATLAB says it's negative, and this is our result. And algebraically, when you have feedback, it's just simply g of s over 1 plus g of s times h of s. So if it's unity, right, h of s is 1. So that means y of s over r of s is g of s over 1 plus g of s. Okay, just a couple more slides. We'll look at the min-real function. So what min-real does is if you have a transfer function and it has a bunch of large numbers as the coefficients for the numerator and the denominator, and say also there are some poles and zeros that can cancel, the min-real function will simplify the system down to its most basic form. So here's an example. We have a big transfer function with big numbers, right? So we have 12, 205, 1066, and then what it does is it divides everything by common denominator. So then we have a leading term here of 1, right, instead of 12, right? Everything is kind of divided by 12 here. So it'll do that automatically for you. And lastly, before we get into lab tasks, which you're going to have to do yourself, we will look at a step response. So how you do a step response in MATLAB is use the step function here. So the first input is going to be the system that you want to do the step on, right? The step is going to be input to this system, and then the time is saying, okay, you're doing it with respect to some time matrix or some time array. And so you can make that time array by saying, 1 to 100 in increments of 0.01, something like that. So you need to specify the time before you do this step. Okay, so then you say you want to store the results of the step input into arrays y and t. So t is going to be the time array, right? It's going to be on the x-axis, if you will, and then y is going to be the response. I like to think of it maybe as, a displacement, and that's going to be in the y, axis, if you will. Okay, so then we can plot that. Those lab tasks, right? So that you get something like this. So you can go ahead and try out this code. This is it for the first week's lab handout. Please email me if you have any questions, and thank you for watching.